Welcome to Algebra 2, Chapter 1. Chapter 1, Section 1 is all talking about parent functions and transformations. Transformations. We learned about transformations in geometry. Transformations is a fancy word for types of movement. Okay, so we're going to be taking our parent functions and we're going to be moving them or transforming them into a new function. Let's start down here. Let's start with our parent functions. What are the parent functions? We're going to identify 8 basic parent functions and label them as constant, linear, absolute value, quadratic, square root, cubic, reciprocal, or exponential. Let's start with this one. This graph is a perfect V. When we get a perfect V graph, that's our absolute value graph. Okay, and it looks like this with our absolute value symbols. Those 2 vertical lines right on each side of the x. That's the absolute value. The definition of absolute value is the distance away from 0. Okay, and we'll get into that here later on. Letter B, this nice little graph here off to the right, that is our square root. And the square root looks like this. Y equals the square root of x. And it makes that function there. Going down to C, when we have a straight line, it's not a linear graph, it's actually called a constant, because it constantly stays at 1. And that looks like this, y equals 1. And that is our constant graph. It goes through 1 and it goes a nice horizontal line and stays at 1. At a constant rate. D starts out very minimal, then it shoots up really quick. That's called exponential. An exponential graph looks like this. Y equals 2 to the x. And the variable x is the exponent. Exponential, exponent. That's a good way to remember that. Down here, letter E. Letter E has just a quick little doo-doo right there. That's a cubic graph. Cubic means 3. Y equals x to the third. That's our cubic graph. And then here, we have a nice line. This is our linear graph. This looks like y equals just x. Y equals x. You should have learned about that linear graph in Algebra 1. Probably been talking about linear graphs for a very long time. Letter G, this is reciprocal. Okay, we're not going to get into that. I spelled reciprocal totally wrong. Wow. And I'm not going to write the function out. We don't talk about that one too much. And this one, H, is our quadratic. We will talk about this one a ton. Our quadratic graph. This looks like y equals x squared. And this is called a parabola. This u here, we call that a parabola. We'll get into that later. I'm going to skip these. I'm going to go down to some definitions here. The parent function. The parent function is the most basic function in the family. All right, transformation. Transformation, we kind of talked about that already, but transformation changes size, shape, position, or orientation. Translation, we learned about this in chapter 4 in geometry. It is a type of transformation that shifts the graph horizontally and or vertically, but does not change size, shape, or orientation. Okay, so all we do is take it and shift it. That's all it is. A reflection, we should all know what a reflection is. I'm not going to write the definition there. I could write an image here. We have a point. We have a line. And that point's reflected, so we have another point over here. That's a reflection. Okay? We should all know what a reflection is. Vertical stretch and vertical shrink. Okay. Vertical stretch and vertical shrink goes back to right here on your Algebra 2 front page on Schoology. If you go to the top, a guide for transformations, right here, this will give you a list of every type of transformation we'll be using in here. Okay, horizontal transformation, vertical, reflection, vertical, and horizontal. Okay, so we want vertical, what is this? Vertical stretch and vertical shrink. So a vertical stretch, let's go to vertical stretch. Right here, a times f of x, where a is greater than 1. Okay, so if I have, let's just say this equation, y equals 3x. This is a vertical stretch of 3 because it's in front of my function x. Vertical stretch. And what's a vertical shrink? Well, if I go back here to my thing, vertical shrink, a times f of x, where a is between 0 and 1. A is between 0 and 1. So y equals, we'll say 0.5x. This is a vertical shrink. Vertical shrink. Okay, that's a good start. Again, on Schoology, on the top, right here, this is all sorts of transformations. We need to come back to here a lot. So if you get this page down and study it, you'll be in a good spot. All right, let's go back to our notes. Here are our parent functions. Our constant is f of x equals 1. Our linear, f of x equals x, absolute value f of x equals absolute value of x, f of x equals x squared for quadratic. Here it talks about the domain and the range. Domain. How do I remember the difference between domain and range? Domain is left and right. I think of, if you can imagine, a king standing at his castle talking out to the people with his arms out wide. this is my domain. Thinking as far out wide as you can reach your hands, as far as you can see left or right, that's your domain. Your range is up and down. Yeah, I think of, when I hear the word range, I think basketball. And I know basketball players can jump really high, right? Range. Range is up and down. Up and down. Okay? Yeah. Let's move on. Next is 1 through 4. Identify the function family to which f belongs. Compare the graph f to the graph of the parent function. So we're asked, what function family does this number 1 belong to? Well, it is the linear graph. Linear. Okay? And the linear function is y equals f of x, where it's just up 1 over 1 the entire way. Okay, so there's our parent function. I'm going to erase this arrow so we can see our new function. Okay, f of x equals negative 1/4 x plus 8. Each thing, that negative, the 1/4, and the 8 have something to do with the transformation of our graph. Every one of those things. Let's start by looking at the negative. Let's go to our guide of transformations. Look to see where you see a negative f of x. There's one spot right here. Okay. When we have a negative f of x, like we do here, we have negative 1/4 x. That is a reflection over which one? The x-axis. Reflection over x-axis. The 1/4, we just talked about that. The 1/4 is what? It's a vertical shrink. And the plus 8. Plus 8. To find that, it's right here. F of x plus k, our function plus k moves the function k units up. So that plus 8 moves it up 8. Each part of the function in the linear graph, whatever it is, the negative 1/4 x, changes our graph. Okay, every part. Number 2 here, we have f of x equals negative 3. Well, what's the family function? That's our constant. The constant family. The constant function is right here at y equals 1. This new function is f of x equals negative 3. Okay, so what's our definition? We could say a reflection over the x-axis and then down 2. Or we can just say down 4 units. Down 4. Okay. Moving on. Number 3. Number 3. Well, what family does this belong to? This belongs to our absolute value. What does that look like? Well, this is up 1 over 1 the entire way on both sides. Okay. And this has a 5 in front of it. Go back to a guide of transformations. That has a 5 in front of it. So it has an a times the f of x. And a is greater than 1. We should be saying vertical stretch. Okay, so we're going to say vertical stretch. And that's all it is. And you can say by a factor of 5. Number 4 here. Number 4 is a little more difficult. And there's a lot going on. What family does this belong to? The quadratic family. And that is where y equals x squared, right? That's our basic parent function. That starts at 0, 0. We know at negative 2 it's at 4, at 2 it's at 4, at negative 3 it's at 9. Okay, so it looks something like this. Alright, so looking at our graph, just think, look at our vertex. Where does our vertex go? It goes here to here. Well, how far over does that go? It goes right 1 unit and up 4. Okay, that one's easy. We can just look at our vertex and say, well, how does it move? It goes right 1, up 4. Looking here, and we had that plus 4 at the end, so that's a vertical movement up because plus k, and there's plus 4. But then it went left or right, and it had this movement in it. And notice, horizontal movement. If it's x minus something in that function, it moves right. If it's f of x plus something in the parentheses, it moves left. Going back here, comparing our graph, x minus 1, going back here, x minus h, x minus 1, moves it 1 unit to the right. Okay, moving on down here. Okay, I'll do number 5 for you, but you guys can do the rest. Actually, I'll do number 5 and number 7, because number 7 is absolute value. Graph the function and its parent function, f of x minus 7. If you don't know how to graph this, or what each part of that graph represents, meaning you have no clue how to graph this, make an x and y chart. Okay, where you plug in a number for x, where you have 0, y equals negative 7. Because 0 minus 7 is negative 7. Okay, 1 minus 7, negative 6. Right, and then plot these points. Okay. You might know that this is a linear function, right? So this is my slope, and this is my y-intercept. Okay, so my slope is 1, my y-intercept is negative 7. So just go up 1, down 1, up 1, down 1, and make this line here. What is my parent function? Well, it goes right through the origin. It goes up 1, over 1. Okay, so how does this graph move? Well, if you need to, go back here. We have f of x minus k. So it's a vertical down. How many ever movements k is? So down 7. So that's what we'll say, down 7. Number 7. I'm going to skip number 6, going to number 7. This is our absolute value. Y equals x. That's what family it is. I'm going to graph my parent function first. X, y. Okay, the absolute value. I'm going to start with 0. The absolute value is 0, 0. So 1. How far away is 1 from 0? Well, it's 1. So at 1, it's 1. How about negative 1? How far away is negative 1 from 1? Or from 0? It's 1 unit away from 0. Negative 2? How many units is that away from 0? 2. Same with positive 2. Okay, that's why it makes this nice, perfect V. But now we have that function plus 1. Well, take each of those and add 1. So if we're at 0, it's 0 plus 1, 1. If x is at 1, y is going to be at 2. It's going to go just like this. How does that move? Up 1. That's it. That's all I want for those 3. I'll skip those. Number 11. Identify the function family of f of x equals 1/3 times the absolute value of negative x plus 4, and describe the domain and range using a graph calculator to verify your answer. Don't use a graph calculator. That's fine. Identify the function of family. What is it? Okay, I'll use my graph calculator here. I'll pull it up. Okay. We'll get that going in a second. Describe the domain. Oh, let's see. Okay, so that's all we have to do. We just have to plug this in and describe the domain and range. So, y equals, this is 1/3. Yeah, I'll go in parentheses. 1/3 times the absolute value. If you can find the absolute value on here, let me just check my calculator on here. It's a little fuzzy. Absolute value is, where is it? Okay, give me 1 second. Okay, after my research, you have to click this math button here, scroll over to numbered, and hit the ABS, absolute value. And now we just type in negative x, go to the absolute value plus 4, and then hit graph. Okay, let's see what this does. Okay, so looking at your graph, I wanted you to think domain and range. How far to the left does it go? Goes to negative infinity, right? How up to the right? Same, goes to infinity. So the domain is what we call all real numbers, and there's our symbol. All real numbers. So I'll write all real numbers and then the symbol. All real numbers. And our symbol for that is this weird looking R. It has 2 vertical lines there. All real numbers. Okay, what's our range? What's our range? Well, it's actually everything up here, right? This graph covers everything up here. So what point is right there? That's our minimum point. It's 4. It's 4. Why do we say that? Because we have a plus 4 right there. Our range is y is greater than 4. Everything greater than or equal to 4. 4 is included. Okay. All right, moving on. Next problem. Next problem. Last problem, right? Or do we, yeah, this is it. This is it. The table shows the distance a biker rides in his first team relay competition. What type of function can he use to model the type of data? Well, at 1 it's 12, at 2 it's 24, so if I were to just quickly graph this, at 1 it's 12, at 2 it's 24, at 3 it's 36. It's just this constant graph, right? A constant linear graph. It's linear. Why? Because the amount in distance correlates with the time. And I kind of describe it using the graph as well. If the biker's teammate rides at the same pace but leaves an hour later, what type of transformation does this represent? Okay, so he leaves an hour later, so at 2 hours he's at 12. At 3 hours, or at 3 hours he's only at 24. So we're right here. We move to the right, down, left, up. What do we do? We only go 1 unit right. That's it.